Okay, here's an example. Scores on the critical reading section of the 2019 SAT reasoning test are approximately normally distributed with a mean of 497 and a standard deviation of 114. So when they say approximately normally distributed, we know that we're going to be using this graph shape. And then the mean is always in the middle of a normal distribution. The standard deviation is the amount that you're going to add and subtract to that mean. So I'm going to take 497 and I'm just going to keep adding on 114 for 3 standard deviations. So plus 114, 611. So that goes here. Then I'm going to add on another 114. So that tells me that 2 standard deviations is 725. And 3 standard deviations above the mean is 839. Then I'm just going to restart at 497 and start subtracting 114. So 1 below the mean would be 383. Then 269. And then 155. From here, I want to answer my question, what percent of students scored over 611 on the critical reading section of the SAT? So we're concerned with, what percent of kids scored 611 or higher? So what I notice is, based on where, if I start at the mean, 611 is 1 above the mean. So I need to access my knowledge that 68% of scores fall above or below 1 standard deviation. I'm interested in a certain percent that's outside of that. So I start by saying, okay, 100% minus 68% is 32%. 32% of the scores are more than 1 above or below. So basically, I just found that this part and this part add up to 32% of the scores. I don't really want this lower part, so I want to cut this number in half. I want to divide this by 2 to get my final answer, which is 16%. Dividing it by 2 essentially just took out half of my data that's outside of 1 standard deviation.